Hey, hi everyone. I hope everyone is doing great. So, we are back with yet another use case of system design, and typically, we have covered mostly concepts like individual system components and haven't put in a lot of effort on seeing, I think, how all of those individual components come together. So today is yet another attempt to bring all of those concepts together and design a messenger system. So messenger systems basically could be like a Facebook messenger, it could be a WhatsApp. If you have been around in tech for long, you would also remember the Yahoo Messenger. There's also obviously your Slack based messenger services, right? So all of those messenger services, we are going to cover under this particular topic, and we are going to follow the same template that we had last time for Google Drive, which is we will have a high level design discussion, we will have a low level design discussion, we'll go in the user estimates, we'll talk about the data models, we'll talk about the API components, and then finally wrap it up with a detailed discussion on the system components, right? So let's start with the high level design, right? So high level design, what are the functions that this system should be able to do, right? What a messenger service should be able to do. So you can see that, I think, yes, obviously you should be able to send messages, right? So you can send like text messages, you can send images, videos, and audio messages to each other, right? So, and one call out that I would say when you are explaining this, also mention that the receiver, right, can be either online or offline, right? You don't know about the user, right? Groups, yes, like in WhatsApp, you can create and join groups. In Facebook, you have groups, right? In Slack, you have channels, correct? So very similar to that. File sharing, yes, you do file sharing with one another, right? Voice and video calls, you can give this as an option because this is definitely going to put additional load on your servers, right? And then notification services, pretty important that you receive notifications for your new messages, calls, and any other important event that your messenger service is providing, right? So this is how I think the high level design will look like. We have two users, Bob and Alice, basically trying to interact with another. Alice is basically sending a message, and if Bob is online, then Bob receives the message through the chat service. The chat database obviously stores their, let's say, history of chat, right? There's another concept here that you need to be aware of, which is the transient intermediate service. So, what happens if Bob is offline? What do you do then? Bob is not going to tell you that when is he going to come online or be offline, right? Your service should be able to identify that, right? So you have this intermediate transient service that, in case if Bob is offline, will store the messages in the transient DB, right? And then it will, when Bob is obviously online, you will see that this transient intermediate service will pass on the will pass on the message to the chat service here, right? And then that chat service is again going to uh, ensure that Bob is online and then passes the messages to Bob, right? So this is your high level design, right? Always remember that high level design talks about the functionalities, right? What are the functionalities that you want in your system? Now coming to the low level design, right? Uh, Low level design more technical in nature, right? So for example, your system should have very high availability, right? 99.9999, right? I mean the five nines or the six nines. Maintain several copies of chat that the client will basically use periodically, right? You should also obviously have a very highly reliable system, which means that when your users are interacting with one another, there should be no chat messages lost during the interaction, right? Uh, Obviously, very low latency. Why? Because you can't actually have latency, which will result in a very bad customer, user experience. Because let's say I have sent out the message and the other person is still waiting, even though that person is online, the person is waiting for the message to appear, right? So that's not a great system low level design functionality to have, right? And then in memory, let's say caching, right? For example, again, you can use solutions like Amazon DynamoDB Accelerator. But the main point that is to be remembered is that these are primarily catering to keeping the latency level very low, right? So caches are like accelerators. I think those solutions have to be used to keep the latencies in check. And then obviously your system needs to be highly scalable, right? So what do you mean by scalability here is that you should be able to horizontally scale the DBs as you are creating and maintaining local versions in different countries, right? You can also think of master slave nodes replication, right? And then creating copies of those, which will also help you in some sort of failure tolerance, right? I mean, in case of failures, how do you deal with uh, failures, right? So this is also going to help you, right? So low level design, talk about this, and then your next idea should be to give a estimate of what are the storage numbers that you would need. Secondly, what are the, let's say, bandwidth or request numbers that you're going to see? And then, because you're also going to handle media, right? Talk about that part also separately. I think in a lot of system design interviews, you'll also see like what are the bandwidth requirements, right? I mean, for a particular service, I have deliberately opted for it. I'll leave it up to you guys to do the calculation. All the numbers that I have presented can be used to calculate the bandwidth also, depending on your network, whatever limitations, right? But here I'm just going to focus on the storage and the request part. So, for example, the daily active users, you can start with whatever number, right? I mean, here we start with 10 million members, 10 million users. Now, assume that they send out four messages to five different people on an average daily, right? So that translates to 100 million messages per day, right? Uh, how did we arrive? Like, look at this calculation: 10 into 4 into 5, and by 2 is done here because when I am sending you the message, you are also basically connected to me, right? So we are two users basically that are communicating with each other, right? We are not independent. So I can't be sending messages to myself, right? Although WhatsApp has introduced that feature also, but I'm pretty sure that it counts it as a separate user. For you, it is appearing as the same user, but those are two different users with two different user IDs, right? We'll talk about that in the data models. When what do you mean by user IDs, right? So 100 million messages per day, right? Now assume that 10% of those messages are actually used to send out media files, right? Such as your video files or your pics, right? Your documents, all of that, right? How many of those messages are there? 10 million messages per day, right? 10% of the overall messages, right? Now, there is request per second concept. Like, how are you going to design, like, your requests, or like what is the number of requests that you are going to get per second, right? So you had 100 million messages, you're looking at 24 hours and 3600 seconds, you're basically looking at 1.2k uh, requests per second. This is something, queries per second, that we had discussed. We did a similar calculation in drives also. When we were doing Google Drive, we had derived a query per second a number, right? So now bringing it all together to use this storage estimates, right? So storage estimates, for example, let's assume each message is around 100 bytes, right? So 100 million into 100 bytes is roughly 10 billion into 1 byte, which means 10 gigabytes per day, correct? Each file, let's assume, is almost like 5 MB, right? So 10 million into 5 MB, roughly 50 terabytes per day, right? Go through the calculations because I've tried to simplify it so that you can break it down into the least, simplified format, and then arrive at this number, correct? So I think storage, you can get an estimate. Messages, activities, you can get an estimate. Requests per seconds that you are going to be able to support on your network, that also you are going to get an estimate. So user estimates finally conclude that these numbers are based on assumptions, like you're sending four messages to five different people and 10% of the messages have media information. Everything, every calculation changes based on your initial assumptions, right? No one is going to hold you accountable or put a gun to your head and say, no, I want like exact numbers. No one knows the exact numbers, but assumptions are what will drive your final numbers and user estimates, and it should be like reasonable, right? Then coming to the data model, so typically in data models, if you remember, right, we do talk about tables, right? How are the table structures going to look like? What are the information or columns, that we are going to use? I have tried to keep it simple, but you can add more to those data models. There's no limit to it. But I am going to restrict the table and entity relationship discussion to user groups, and messages. Right. So, for example, I'm looking at a table called user, right? That is going to store my user ID, username, and phone number. Right. ID being an alphanum and the other two being varchar. And then basically that has a relationship with groups. So one user can be part of multiple groups, correct? So user group, basically this groups table is also uniquely identified by a ID and all the messages it stores. How are these two connected, user and groups? Through a user group, right? It has a user ID, it has a group ID, and it has its own user group ID, right? And then you have the messages, correct? The messages will have its own ID, it will have a group ID. Like if I have to look at all the messages in a group, right? If I have to look at all the messages of a user, then I need to have a user ID. The type, right? Type of message will be basically whether it's a text message, file, whatever, pic, video, etc. Right? The content, right? What is the type of the content? Uh, the important part is, I think, these timestamp: sent at, seen at, delivered at, and what is the status. Status is nothing but it'll help you understand whether the message was successfully delivered or is it being still delivered. Right, most of the times, like in 99.99% cases, your status will be successful only, but in some cases where it is not, you should be able to track it. Right? So you would also see, I think, in other discussions, for example, people are like talking about chat and chat groups, right? I probably would also include it, but like I think it's not required. If you have groups, if you're trying to like cover discussion on how are these tables actually related, so let's talk about those indeed. So user table basically is going to store each user's information, right? And it is related to the group table. Now your user is also going to be part of the groups, and you need to have a mapping of user and groups, right? So for example, I am part of five groups. How do I know which groups are those, right? And if I'm sending, let's say, a group message, right, how do I send that message? So what will happen in that case? Let's say, for example, if you're sending a user group message, user IDs that are all collectively part of a group ID will be fetched from this table. Uh, then those group IDs, all the messages that are part of that messages, right? So let's say you're sending. Let's keep it simple. Let's send an let's say birthday message that you're sending in a group, right? So how does that function? The birthday message, the group will have, let's say, some 10 people. How do you know those 10 people? You will come into this mapping table, user group, where you will see what are the users, right? uh, those users, and as you said, like, you will basically also have a message, right, that you want to send happy birthday to, whatever person in that group. That is the message that is going to be looked into. What groups it needs to be sent? Maybe you're sending it in multiple groups or you're sending it in one group, right? What are the users associated with that group, right? Content, all of the other details, right? So essentially, when you're creating a message, right, the information that it fetches is whether you are sending it, to a user directly. So if you're sending it to a user directly, right, how will it happen? This is the starting point, right? You look at a user ID and then you look at a message ID. if you're looking at a message ID, then basically you will have content, seen ads, sent at, delivery. All the information related to group ID will not be required, right? Because you are just sending the message directly to a user, right? In some cases, I think what people call that as a chat, right? Like a two-way communication that is happening, right? So you can have a separate table also, which is chat, which is like an ongoing, I would say, channel, right? That you've already established. Maybe a chat between two users can also be stored in a separate table, and you can assign a chat ID to it. No problem in that. I think you can discuss that also. But I am just keeping it very simple, not too complicate. I think the data models and give you like how the entities and table relationship works. Uh, so far, I think the concepts that I have covered, I think hopefully make sense for you. If not, please leave comments, and I'll get back to you with the problems that you have asked. Right. So I think next coming to the APIs part, APIs will be very important, uh, simply because I think it gives you the understanding of how, like, I think, let's say two systems are communicating, right? So if you're talking of, for example, get messages, delete messages, retrieve messages, new messages, right? You should know, for example, what are these APIs going to help with, right? So get messages basically, like, you need to have your user ID or a message ID and the message, right, that you are uh, seeing. Where is it used? Like, so in WhatsApp, for example, you are clicking on, you, so you have a list of friends, right, that are there in your WhatsApp. You click on where you see like new messages, right? Typically it comes in green icon where you say like three or four, whatever the number, right? The chat message. That is, when you click on that, that's basically a get message. It will tell you all the get, it will give you the list of all the messages that have been sent to you, right? Of course, there is new messages and old messages that you can, like, also further segregate into this. A new messages, will have typically those new message icons, and old messages you have to scroll through, right? That's also be possible in this. Delete messages, you can do that, right? I mean, delete for everyone. For example, now you see, right? I mean, delete message. Uh, you get the option delete for me, delete for everyone, right? So that's going to be part of this API. This delete parameter here is actually checking whether the message is actually deleted, or like you're deleting an existing deleted message, or you're deleting a message that is there, right? So there's that delete message part. The retrieve message again. Um, so you would see, if you've used WhatsApp a lot, if you scroll, like there is a limit of the messages that you scroll. Beyond that, when you start scrolling for older messages, right? Let's say 3 month old message, WhatsApp has to retrieve it, because putting all of those messages that you have sent, let's say over the last 6 months, either on your side, which is your client side, your your mobile app, or on their client server that is handling this, is not a very good system design practice, right? So you store it in the database, retrieve it only when you need it, and you basically use the sent at timestamp, right? So you had sent it at, let's say, 3 months back, right? So you want the user to get all the messages that were sent at whatever 3 months back, right? And then you have the new messages, right? The new messages basically, you get that icon, right, where you click on it, to user ID, from user ID, and then you send out the messages, right? Now coming to the groups API, right? You can perform the following like functions. You can join a group, you can leave a group, you can create a new group, you can delete a group, right? So what will be the API is going to look like, right? To join the group, you basically have a group ID. You tell all the users that will be part of that group, right? That have to be there, and whether the group exists or not, right? So I can join an existing group. I can also join a new group. If the group exists, then I just push a user ID to that group. If not, then I create a new group. Right? I can also leave a group, right? I can create a new group, right? Uh, Group ID and then the collection of user IDs, right? Is what is required in a new group. And then deleting a group, right? Again, like whether the group exists or not exists, typically like a check, but a collection of user IDs that will be out of that group once the delete the group is happened, right? So these are how I think API discussions should be. I think most of the API discussions that I have been part of look at the breadth. not look at like how in each API what are the parameters that I need to like pass. That's not like I would say a product manager's job. The product manager should give a high level idea of this is what I'm looking at when I'm saying I want to do messages, right? I should be able to delete my message. I should be able to retrieve my message. I should be able to also create messages, and I should be able to get all my messages, right? So these are like four, let's say, pillars on which you will, for message design API, you will typically have questions with your technical team. The details of what parameters to pass, what should be the file types, whether it should be a JSON or whether it should be like any other format. All of that I think are very tech discussions, which you can probably go into if it is a company like let's say Google. Google might expect you, but I think I'm talking of the 90% companies. They'll be more than happy if you're just listening down, your thought process on APIs. Correct. So I think so far we covered the high level design, the low level design, estimates, data models, APIs, and now coming in together to bring it all under our system components. So I'm not going to immediately jump into the system component, but I am going to tell you is that system components will be typically comprised of our individual components that we have discussed in the past. You will have your website, sorry, uh, web clients. You will have your mobile clients, right? Mobile app, web apps, right? You will have gateways, correct? You will have your let's say load balancers, right? You will have your caches, right? You will have your application servers or some, I would say, servers that are handling the application load, right? Then you will also have your, let's say, databases, right? You will have your caches, you will have your message queues, right? And then you will have your, let's say, some sort of maybe third party services for notifications or storage, right? So this is typically 8 or 10 components that you will see, and then how are they interacting is what will constitute your system, final system design, right? So coming to the design of our messenger, how is it going to look like? Lot of components, we will go into the details of each of those, but I think you can bring in more components. This is not like, I would say, probably the most realistic or the probably the best design out there, but it is good enough to convince the other person that you are talking of, let's say, the understanding of the components, understanding of how these are interacting with each other, talk about the trade-offs, and I think it should be good, right? So let's start with, I think, how the flow is going to look, right? So typically you'll have your client, right? You'll have your mobile apps, right? Web is also available now for WhatsApp, for example, right? You'll also route these requests through an API gateway. Now, what are the API gateways going to help you with? So API gateways will support multiple protocols, right? Like for example, you will have a WebSocket. Why is a WebSocket needed here, and why not, let's say, polling and long polling or short polling, right? So remember, I think WebSocket was bidirectional, right? Here it makes more sense because every time a server needs to basically push on the message, right? So if you go back to our original system design, and if you look at polling versus WebSocket versus sent event, right? So WebSockets allow you for persistent connection, right? Uh, Obviously, it is compatible with HTTP protocol, but the biggest reason that WebSocket is more useful in designing or being used in a messenger is because it can pass data in both the direction, and there is no additional HTTP request. So why is this important is because the number of messages that you're sending are very, very high, right? You don't want to be opening any, like every time there is a message sent, you don't want to open like HTTP requests every time, right? So we saw that with polling, for example, right? Requests are made at regular time, and it has performance issue if there are too many requests, right? Which is what we are actually trying to counter. because we don't want performance issues coming in, given the estimates that we had shared, right? Remember the number of messages that we were sending, right? If you go back and look at the number of messages, 100 million messages per day. That's a lot of messages, right? So you definitely won't be using, like, polling, right? So WebSocket, again, are, like, I would say, uh, probably the right choice, correct? And you can also bring in services in your API gateway, for example, your authentication, your rate limiters, and version controls of the APIs, right? So this is, like, I would say, how you start building on the system, final system design, for your use case. Load balancer required because uh, typically you want to kind of, I would say, shadow, like, you want to, I would say, protect your servers, right, by not bombarding them with too many requests, right? So required between multiple client servers. So here, between the chat server, or let's say the transient server, right? The load balancer will figure out, I think, what queries need to go to chat server, transient server, balancing it out, right? Uh, you will also see, I think, this chat server and transient server coming and now interacting with the chat DB. Remember, in the high level design, I had talked about what is the use of a chat server and a transient server. So, chat server and transient servers, basically, distinction is, if your users are not online and are offline, then you can't use the chat server, then you're using the transient server, right? Correct. And your standard, like, I think, message queue basically is uh, allowing you from the load balancer to send out messages in a queue format, right? So basically, you are receiving a lot of messages, and let's say those 100 million whatever, like, messages that you have calculated, if you're bombarding all of that directly to your chat server or transient server, they are going to be issues, failure issues will definitely happen, right? So you need some sort of message queue which is going to help you with first come first kind of, like, arrangement, or maintaining some sort of, let's say, serial structure in place, so that the 10 users, for example, that had sent the request in the last half an hour are the first ones to be, uh, let's say, diverted to the transient server or the chat server, right? So that's the use of this message queue here. Caches, I think, obviously can help you with keeping, I think, your old messages in the media files, right? The old messages in the media files that are not being used, you can use those, and put them in the cache. Can use, I think, any, like, you can use Redis or Memcached, because both of support, like, have support for least recently used. Here it will come to the trade-off between whether you have the money to buy, like, invest in something like Redis or Memcache. Memcache typically lower cost. Uh, and obviously, that caches are there because you don't want to hit the DP directly, right? Also, Redis supports more data types. If you remember from our lecture, from discussion on caches, right? Memcache has very limited support, right? So if you're trying to, like, look at multiple data type supports, then definitely go for Redis, high or to higher cost. Use of message queues, right? Where are the message queues actually coming into picture into all of this? So obviously, as I mentioned, like, you need to retrieve the messages from the chat or the transient server, right? When you get back the response from the chat DB, then you are also going to be actually sending it back to the client, right? That had the request, right? So message queues are going to basically control that, right? And message queues also play an important role in the notification service, right? So they are also sent to the notification service. So for example, 10 users are supposed to get the notification. How do you know which one of the users get the first notification, right? So, and you receive, let's say, a bunch of chat data from your chat database, right? Through either a transient server or, like, let's say, directly from cache. How do you know which notification is to be sent? So the message queue is essentially like serving very important purpose here. You're retrieving your messages in a queue fashion, right? Either from the chat or the transient server. And also the most I would say important part of the message queue is sending out messages to the notification service back to your app server, which could be hosting a web or a mobile, like, messenger applications. So in a first come first, or in a very queue based manner, right? So here, for example, this notification service, right, is going to receive the messages from the message queue, right? And then it is going to send those messages back, to the clients, right, which could be your mobile app, right? So now coming to the last part, I think, of this system components is the notification service itself. Um, Essentially, this is going to have a logic in place to see whether your user, right, which is your client, is basically active, right. If it is not, then essentially the message queue gets the message, right, directly from the chat DB, right. And then another important part is that you're using Apache Kafka sort of a service, and then Firebase Cloud Messaging is used to send out the push notifications on Android devices, and Apple push notification on your iOS devices, right? So overall, I think we covered right from your API gateways to, your chat DBs, to your transient server, message queues, caches, notification services. The one part that I think which has not been, like, talked about is your API services here. So typically, I think API services will be predominantly used in, as we had discussed, right, to retrieve your message, to let's say delete your message, to join a group, or to exit a group, right? So all of that will be handled by this API service. Do you need it separately? Maybe not in the initial stages, but you'll need it at some point. Why? Because the number of calls, for example, that would be made, would be pretty huge. 100 million, if you remember, right, the number of messages. So that many function calls, right, might not be handled directly in your, let's say, load balancer or any other layer in between, right? So it's essential you have it separately, and then that essentially interacts, either directly with the DB, or, through your transient server or through a chat server, right? So this is how I would say probably you should structure your discussion. Uh, Keep in mind, I think, yeah, the core components, and answer those in form of trade-offs, right? And do touch upon, I think, the parts wherein you are talking about the design of, let's say, or including, I think, the caches, or including the load balancer. See, these are not must to have parts. I could still, like, have a design without a load balancer, without a cache. But then I think modern systems, right, are invariably going to have these components without fail, right? So such is the scale, right? So I hope you found this video useful and interesting. Please do leave comments on any other system design, use case that you would like to see. I am pretty soon going to cover one of the, like, I would say, challenging system design use cases, which is going to be either on designing an Airbnb or a Redfin kind of a service, right? It will have its own additional components of machine learning systems. In addition to whatever you're seeing, like in your standard, whatever, message queues or caches or load balancer, you're also going to see the system design components from a machine learning perspective. Typically very useful if you are appearing for, let's say, product roles with focus on AI and ML, which seems to be a lot in demand in the market right now. So do check out that video as well. I am going to be posting that pretty soon. So until next time, please subscribe to my channel, like my videos, and stay safe.